In dihydroxylation, two vicinal OH groups are added to an alkene. In other words, one OH group will go on one carbon of the alkene and the other OH will go on the other carbon. And you can prepare either a syn or an anti-diol. It just depends what reagents you use. So anti-dihydroxylation can be done by starting with an epoxide. And we saw how to make an epoxide using a halohydrin, which is one really common way. Another way is to use a peroxy acid, and that has the functional group it's CO3H. So it's kind of like a carboxylic acid with an extra oxygen put in there. So there's an oxygen-oxygen bond that ends up being reactive, kind of in a radical reaction. And there's a variety of different types of peroxy acids that you can buy. The most common one that we use in the lab is MCPBA, and that's soluble in organic solvents. So you can run your epoxidation reaction with your organics. So when you make an epoxide with a peroxy acid, it is stereospecific, meaning that if you start with a cis double bond, then you'll wind up with a cis substituents on the ring. If you start with a trans double bond, your substituents will be trans. And the reason for that is that this oxygen is just kind of, in a concerted reaction, comes down and just plops on top of that double bond. So the substituents can't switch around over the course of the reaction. Once you've got your epoxide, then you could use hydronium. You could also use an alcohol. You could use, as the nucleophile. You could use OH, hydroxide. All of those will ring open an epoxide. In this example, the oxygen of the epoxide is protonated first. It's a proton transfer. That makes the carbon of the epoxide quite electrophilic. So then the water nucleophile, the lone pair, will form a bond with the carbon of the epoxide. And at the same time, the oxygen will ring open. This is really the same type of reaction that we saw with the bromonium ion during halogenation reactions. So then in the last step, we get that proton transfer. So you can also do syn hydroxylation. This one will lead to trans because the same reason that you have anti-addition with the halogen leading to the trans product. But you can also get that syn hydroxylation using potassium permanganate or osmium tetroxide. And in both of those cases, what happens is you have your oxygens bonded to your metals, and they both just come into the same side of the double bond and donate those oxygens to give the cis diol as the product. So that's syn addition.